Okay, on this problem, we have a solid that lies between planes perpendicular to the x-axis at y equals 0 and y equals 2. The cross sections perpendicular to the y-axis are circular disks with diameters running from the y-axis to the parabola x equals root 13 y squared. Find the volume of the solid. Okay, so the key words here, first of all, are circular disks. Okay, and also this phrase right here, diameter is running from the y-axis to the parabola. Okay, so basically the diameter of the circular disks are running from the y-axis to the parabola. So I'll just create a line here, it doesn't matter where, just a random line, and I'll say that's a diameter of a circular disk. Now there's going to be different circular disks because as you can see as you travel up this y-axis, the circular disks are actually increasing in size as this function here is getting further from the y-axis. I'll just pick just one at random here and find its length. So what is the length of that line, which is the diameter of a circular disk? Well, it's the distance between this function and the y-axis. And the distance between that function and the y-axis is this function minus 0 or just this function. So that length is square root of 13 y squared. Okay, so let's go back to the circular disk part of the problem. If a circular disk, basically, if you think of the circular disk being basically a circle, and you are given the diameter of this circle, the diameter being this, square root of 13 y squared. Okay, what is the area of that given its diameter? Well, we know that the area in general is pi r squared. Okay, d is equal to 2r, right? So divide that over. That means r is equal to a half of d. So substitute that in. A is equal to pi times half of d squared. And let's go ahead and input the L in there that we have, the square root of 13 y squared. So it's pi times 1/2 square root 13 y squared. Okay, which means that our area, let's see, you square this out, and that half becomes a fourth. The root goes away, so it's 13 pi over 4 y to the fourth. That's our area function. Okay, area of one disk. We'll integrate that in order to get the volume. As you know, in order to find the volume of a region, you integrate its area. Okay, we found the area of one of these disks. Now we'll integrate it from 0 to 2 to find what its volume is. Okay, so v will be equal to 0 to 2, our y limits, lower limit to upper limit there, of 13 pi over 4 y to the fourth dy. Okay, pretty easy integration there. You got 13 pi over 4. This becomes y to the 5 over 5. Integrate from 0 to 2. Okay, and not going to spend a lot of time on that. That will end up giving you 104 over 5 pi. And that's the volume.